Hi Science2 kiddos, I'm going to walk you through how to draw the orbits on paper here very quickly. So we're going to draw an elliptical orbit and a circular orbit. You'll need a blank piece of printer paper. This is just a recycled piece of paper, it's one of the old seating charts. But if you don't have this, you can use lined notebook paper as well. You'll need 2 pins of some kind, so these are just tacks, or you could use nails from a tool set, or needles, or anything that's going to be able to just hold string in place. You'll need some kind of string. You could use a shoelace, this is a string from a broken blind. If you have yarn at home, that works well, or I strongly encourage dental floss, works really well for that. You'll need a pencil to draw with initially, and then you'll be using markers and pens afterwards. A calculator to do a little bit of math, and a ruler to do some measurements. Doesn't matter if it's inches or centimeters, as long as you're being consistent. You can also use your phone to do both the calculations and the measurements. A lot of phones come with a measure app. You can see titled measure there in the center left. All right, we're going to start by drawing the ellipse. So the first thing you want to do is place a pin right in the middle of the paper. You want it to be dead center. If you're not okay with sticking tacks into the wood that you're working on, I encourage you to find cardboard to put the paper on. Or if you've got a soft carpet at home, you can just do this on the floor. Maybe put a couple pieces of paper behind it just to be firm for drawing, but then you won't damage anything by sticking a pin in. That's going to be our star. That's the most important point right there, and so I'm just going to mark it really briefly here so we don't forget about it. But that is our center point right there. That's the star that everything is going to orbit around. To draw an ellipse, you actually need 2 focus points. They call them 2 foci. And so I'm going to add my second pin in, I don't know, about 4 centimeters or so below. Nothing that I measured or anything like that. It's okay if it doesn't hold very well. I will just hold that in place with my finger. It's also good just to put a weight on top of your paper so it doesn't shift around too much while you're doing these things. So I recommend using the floss, and so the length of string or whatever you want to use needs to match the width of the paper. So I would just measure out something about that long. You can see it roughly matches the width of the paper there. And tie that into a loop. So this is what you'll end up having. And this is what we're going to use to draw our ellipse. So get the 2 pins in place, drape that loop over both pins. Then I'm going to hold them in place using my finger, but you can bring the string taut using the pencil and then just go all the way around, almost like you're drawing a circle, except you'll see it'll come out as something a little different, an ellipse. And again, I recommend going back and forth a few times just so you get a pretty good confident shape. That's why it's good to use a pencil. And there is your ellipse, rotating around the 2 focus points. And again, I'm going to mark this one here too. That was my second focus point. Now there's a couple things you can calculate about an ellipse, and what I want to calculate is called the eccentricity, which is essentially the roundness of the ellipse. Eccentricity is just a fraction. It's calculated, represented with E. It's calculated as C over A. And both of these rely on knowing the center point between the 2 foci. So this is where the ruler will come in. I'm just going to use my ruler and in centimeters measure the distance from one point to the other, which to me looks like it's about 4.1 centimeters. So I'll divide that by 2. 4.1 divided by 2 is going to be 2.05. So let's just go ahead and assume that that's 2. There's my center point right there. Okay. Now, the C value is the distance from that center point to one of the foci. And since that's the center, I'm going to go ahead and assume that that's the 2 centimeters that I calculated earlier. A here is the distance from the center to the outermost point of the ellipse, which is going to be in line with those 2 foci. So I'm going to measure from the center. I'll draw a dotted line just to emphasize this to that outermost point. So that's my A value there, and that's my C value there, right? So C is from the center to one of the foci, and A is from the center to the outermost point. And again, just to measure my value for A, from the center to the outermost point, it's looking like it's going to be about, looks like 7 centimeters exactly. Now, again, if you don't have a ruler, you can use the Measure app on your phone. They work really well. If you've never used this before, it'll sort of get a target on what you're looking at, and then all you want to do is hover that little center point. I'm not sure how well you can see this, but hover it over there and just say that that's my point right there, and then it will take a measurement from that point to whatever point you choose next, and then it shows you the measurement in centimeters or inches, and then you can get your data from there and clear it and reset it. It's a great tool. Okay, so I'm going to use my calculator just to do the math really quickly. 2 divided by 7 is going to give me 0.285. I'm going to go ahead and round that up to 0.29. There's no unit on that because the centimeters cancel out. And that's essentially a measurement, again, of the roundness of your ellipse. Circles have an eccentricity of 0, and so the closer to 0, the more round your ellipse is. So this is a pretty round ellipse, I guess. If it was a higher number, it wouldn't be so much. All right, next we're going to draw the circle. This will hopefully be a little bit easier. We will, again, use that same center point. Remember, that's our star, so that's what everything is going to be circulating around. And just to keep things simple, we're going to use the same loop that we used earlier, but this time you're not draping it over 2 pins, you're just draping it over 1. Same deal, hold the pin down and draw the top with the pencil, and just go ahead and draw a circle going all the way around. Do it a few times just to make sure you kind of have your measurement right, and there's our circle. And just to use color, I know I used red for the ellipse, so I'm just going to color in the ellipse with red really quick, just to emphasize that was our ellipse right there in red where we calculated eccentricity. And for the circle, I'll use blue. We can't calculate the eccentricity of the circle because, again, circles always have an eccentricity of 0. But we can calculate the distance all the way around. And so just to do a little bit more math, I'd like you to calculate the circumference, C, which you should know is 2 pi r. 2 pi is 3.14. R is the radius, which is the distance from the center to the outermost edge. Again, you can use a ruler or you can use the measurement app to find that number. I'm going to say that that is pretty much 9 right there, 9 centimeters. Use my calculator to calculate that. 2 times 3.14 times 9. And that gives me a circumference of 56.52 centimeters. We do keep a unit on that because nothing canceled out. So that's the distance all the way around. All right, now all that's left to do is label. Again, want to emphasize that that center point we've been working on is our star. You can draw in a little rotating planet on the elliptical orbit. Make it going this way. And, you know, for fun, you can go ahead and name your planet whatever you want. I'm going to call mine Titan AE. And then have another planet making its circular orbit going in the same direction. We'll call that planet Bob. So just take a picture of what you have drawn. I encourage you to use colors to differentiate the two. It's helpful. And make sure you have your eccentricity calculation for the ellipse and the circumference calculation for the circle. Thanks. Oh, and submit a picture of that on the assignment to Canvas.